Hey, it's your boy MJ. All right, rotational symmetry, plane symmetry coming at you. So, symmetry, quick review. If I have a regular old triangle and I want to say, is it symmetrical? I can see that it would be because if I split it right down the middle and then I folded the two halves on each other, they would be identical matches. Okay, so that's standard symmetry. So, in a 2D shape like a triangle, we split it with a one-dimensional line. Okay. The issue with finding symmetry in 3D shapes is that we now need a 2D shape. Sorry, to find a 3D solid symmetry, we need a 2D shape. Okay. Find 2D shape symmetry, we use a one-dimensional line. So when we go to 3 dimensions, we need 2 dimensions. Okay. So that's what plane symmetry is all about. So let's bring in let's get these tools out of here. Let's bring in a good old-fashioned cube. It's going to let me? There it is. Okay, so there's a cube, and as I rotate around, you'll see it is all square faces on every side. That's what makes a cube. A cube is just a rectangular prism with all square faces, okay? If I was to take this shape and then stretch it out, now it would be a rectangular prism, technically a square-based rectangular prism because it has a square base on either end, and all the other faces are rectangle. Now let's leave it as a rectangular prism, actually, okay? So there's a rectangular prism, and I want to find out, does it have plane symmetry, and if so, how much plane symmetry, okay? So the whole idea of plane symmetry is kind of weird, but kind of simple. You need a 2D shape, okay? And just like we were cutting that 2D shape with a one-dimensional line, and technically the line would be infinite, okay? A line segment has 2 endpoints, but a line is forever, all right? So now that we want to split up this 3D solid, we need an infinite 2D shape, okay? And it's hard to think of because it's theoretical, but basically it's infinite wide. So if you're looking at the camera right now, it's forever this way and forever this way, but nothing thickness, right? It's an infinite plane. And kids kind of think of it as being an infinite sort of square rectangle, but in reality, it's, I guess it's almost circular. It's forever, 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 forever in every direction, but no thickness whatsoever. It's 2-dimensionally infinite, okay? Obviously, the computer can't represent that, but what we can do is bring in a rectangular prism again, and this time we'll make it really, really big. That's not the way I want to make it really, really big. We'll make it really, really thin. Can I get even thinner than that? I think it's as thin as it'll let me make it. And let's make it really big this way. And can I make it really big the other way? And let's change the color just to make it, actually, we can make it a whole maybe. Let's make it white. So now I'm going to be able to split this 3-dimensional shape using this sort of infinite plane, okay? That's sort of the idea of plane symmetry. So we can see, if I rotate the shape, it is symmetrical that way, okay? Because, we didn't line up perfectly, but you can see how those would be even. So that would be one line of plane symmetry. So we got one line of plane symmetry. Then if I take this plane and I rotate it, to be, oh my goodness. I feel like if you hold, there we go. I can see it's also, get out of here. It's also symmetrical, again, not quite perfectly. Let's move it over slightly. It's also symmetrical that way. So we have 2 lines of plane symmetry so far, okay? Now, since this one is square based at the top here, I could also go on a 45-degree angle. And that would be a 3rd line of plane symmetry. And if I get it, I need to go all the way to 90, I think. Oops. Oh my goodness. Anyways, let's just assume this was exactly, I guess I could change it. We go to 90 degrees, there is a 4th line of plane symmetry, okay? There's actually more. So that's 4 lines of plane symmetry so far, but I could also, let's see if I can reset this. I could also rotate this on its other end here. Where is that one? Is that one? Yeah. Oops. I could also rotate it that way. And if I just move it down here, oh, it's going the wrong way. If I move it down, we can see another line of plane symmetry that way. Okay, so we had 1, 2, and then the 3, 4 angles, and then this would be a 5th line of plane symmetry, okay? So this has, does it have plane symmetry? Yes. And it's 5 different ways that we have shown, okay? So obviously some things have plane symmetry, some things don't, and the way you decide if it does or not is you take a plane and you cut it and you see, is it symmetrical on both sides or not, okay? So that is plane symmetry. Okay, let's get rid of this shape and let's get rid of this too. Actually, we'll leave it there for now. Let's bring in like a pyramid here, a square-based pyramid, okay? So then we're going to talk about rotational symmetry. So here is a square-based pyramid, and we want to say, does it have rotational symmetry? So now we're looking at, if I rotate it, does it have a match? It's kind of a way to think about it. So if I was to take this prism and rotate it, start rotating it, I want to see, does it ever look the same as it does right now? Okay? Doesn't look the same if I go that much? No. What about this much, this much, this much? As I rotate it, it's never a match. Okay? Until I get all the way around 360 degrees, it now looks the same as it did when I started. So that is what we call a rotational symmetry order 1, which nobody cares about. Everything has a rotational symmetry order 1. I can make the strangest shape. I could bring in all these shapes from the side and put them all together to make this crazy, glumpy, weird castle-looking thing. And if I rotate it 360 degrees, it's going to be the same. So everything has a rotational symmetry order of 1. Who cares? Okay? The way I rotated it, this pyramid only has rotational symmetry 1. But if we look at it from the top, instead of rotating it end over end, I rotate it on this flat plane, I can see that it actually does have rotational symmetry a different way. Okay, so let's start rotating and see what it matches. Not a match, not a match, not a match, not a match. Yes, match. So that's order 1 already, and I'm not done rotating a full 360. So I keep rotating, not a match, not a match, not a match, not a match, not a match. Yes. So we're at order 2 now. Keep going. 3. Oops, 3. 3, there we go. Because now it's matched up 3 times. And then finally I finished my full rotation. And again, we've got a match, obviously. That is order 4, okay? So does this shape have rotational symmetry? One way we tried it, no. The other way we tried it, it had 4 orders, okay? Take a cylinder, put it on there. Same kind of thing. If I rotate a cylinder the same way I just rotated that pyramid, it has infinite rotational symmetry. It doesn't matter how much I rotate it, it looks the same. So that way it has an infinite amount of rotational symmetry. Interesting. If I rotate it end over end, it still has rotational symmetry, but it's a different amount. Let's take a look. If I rotate it this way, no, 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 no. When I get halfway, yes. So order 1 already, and as I finish rotating all the way 360, it has 2 orders of rotational symmetry, okay? So these things are like, they're kind of weird. They're kind of a little, I don't know, theoretical, esoteric, whatever you want to say. They're not really like, it's not like 2 plus 2 is 4, and here's my proof, 2 plus 2, 1, 2, 3, 4, right? It's more of like, you got to sort of think about it. There are tools you can use, right? Like if you have actual, 3D solids, you could like take a piece of paper and try to see if you could split them or not. You could use 3D software like I'm using here in tinkercad and say, what happens when I bring that plane through the shapes? Can I sort of see it? But it's all sort of kind of weird. And like the sort of the things you got to be able to say in grade 6 and 7 is like, does this thing have plane symmetry? Yes or no? And you don't really have to like memorize how many it has. You can sort of experiment with it, right? Someone's never going to come to you and be like, hey, tell me how many lines of plane symmetry a square-based prism has. Like, who cares, right? But you could say, yeah, it does. And you could sort of think about it and talk about it, right? Same with rotational symmetry. So most shapes, every shape has rotational symmetry, at least order 1. The question is, does it have more? That's when it becomes interesting, okay? And we can look at different shapes and say, yeah, like a cylinder clearly has rotational symmetry. How much? Well, infinite if you rotate it one way, and 2 if you rotate it a different way, okay? And then we can take a case like a square-based pyramid, and we can say it has order 1 rotational symmetry, which is kind of like saying it has none. But if you rotate it a different way, it has 4 orders of rotational symmetry. So that's sort of where we are. That's sort of like what we need to know. Do they have these things? And if so, how much? You don't have to know the number, but is it a lot or is it not a lot? Okay. So hopefully that video helps. And yeah, peace.